Alright, these are the notes for Chapter 6, Section 6 on similar triangles. And so two triangles, any two triangles, are called similar if their angles are congruent. Congruent is the geometry word for equal. And their sides must be proportional. And the symbol for similar is a squiggle or a tilde. That's the symbol for similar. So if we look at the two triangles, we have triangle A, B, C, and it has an angle of 45, an angle of 100 degrees, and an angle of 35 degrees. It has a side length A to B of 4 centimeters, side length B to C of 6, and a side length C back to A of 8. Then we have triangle P, Q, R, and if you notice, angle P is 45 degrees, just like angle A. Angle Q is 100 degrees, just like angle B. And angle R is 35 degrees, just like angle C. So their angles are congruent. They have matching corners that are the same measurement. The sides are proportional. So side AB is 4, and side PQ on the little triangle is 2. That's the same proportion or the same ratio as side BC, which is 6, to side QR, RQ, which is 3. 4 over 2 is the same ratio as 6 over 3. If we cross multiply, they would be equivalent. And it's also equivalent to the third side, AC, here is 8, and that's proportional to side RP, which is 4. 8 over 4 is also equivalent to 6 over 3 and 4 over 2. These are all proportional. And so these are called similar triangles. We would say triangle, just draw yourself a little triangle, A, B, C is similar, we need to put the letters in the same order, to triangle. If we started with A, we need to start with P, then we went to B, so we go to Q, we went from B to C, so we go from Q to R. So whatever letter we put first for the first triangle, we put the corresponding letter first for the second triangle. So order is important with the order we put the letters. Triangle ABC is similar to triangle PQR. So those are called similar triangles. Angles are congruent, sides are proportional. Let's look at example 1. The directions say to find the missing sides of the triangles, given that triangle DEF is similar to triangle ACB. And I like to color code matching sides. So side DE, the first two letters, is similar to side AC. So those two sides are proportional or corresponding. I'm going to switch colors. Side EF, E to F, is similar to side CB, C to B. Those two sides correspond. Then I'm going to change to a third color. Side DF, that third side, is similar to side AB, that side. So we have similar sides all matched up. And the angles don't really matter. We don't worry about the angles. All we worry about are corresponding sides. So side DE is 5, and we put that over its corresponding side AC, which is 15. So 5 is to 15 as, we have this missing side here, I'm going to call it X, as X is to its corresponding side of 33. So we set up a proportion, and we're going to solve for this missing red side. And we use cross multiplication like we did in class. So I'm going to cross multiply 15 times X, which is 15X, equals 5 times 33, which I'm going to use my calculator, and get 165. Then we do what we did, divide by 15, divide by 15, and we get X is 11. So we know that this missing side is 11. There's one more missing side, and we're going to set up another proportion to solve for it. I'm going to stick with the same corresponding sides, 5 and 15. So I'm going to set up another proportion. 5 is to 15 as this missing side, Y, is to its corresponding side, 24. So use that same ratio of 5 to 15 to fill in that missing piece. And again, I'm going to cross multiply. 15 times Y is 15Y. And I'm going to set that equal to 5 times 24, which is 120. I'm going to divide by 15, divide by 15, and Y equals 120 divided by 15, which is 8. So this missing side length is 8. So all the sides are proportional to each other, and we use that to find those missing sides of the triangles. This would be 11 meters and 8 meters. All right, on example 2, the triangles are kind of flipped around, and it can get a little confusing trying to match up the sides. Hopefully it's very visual and you can see how they match up. If you're a little confused, use what they give you in the letters. We know that side AB corresponds to side PQ. So I'm going to find side AB and pick a color, and find side PQ and use that same color. Then I'm going to switch colors. I'm going to find side BC, the second two letters, and line that up with side QR. So side BC corresponds to side QR. To me, the colors really, really help here. And then lastly, that third side, which in this one is CA, in a third color, corresponds to the last side over here. And that helps line everything up. So we know that the green side is proportional to the green side on the other triangle. And you can go left to right, small to big, however you want to do it. I'm going to go left to right. 14 is to 7, as I have 10 on the left, and I have X on the right. So that's my first proportion. I cross multiply. That's 14X equals 70. I divide by 14. And I believe that is 5 for X. So X is 5 feet. I do the same thing to solve for the other missing side, which is the blue side on the big triangle. And I use the same proportion I started with. 14 is to 7 as Y. I always go left to right. Y is to its other blue side, which is 3. So you have to line up corresponding sides, and I tend to go left to right just to be consistent. Then I'm going to do 14 times 3, which is 42, equals 7 times y. Going the other way. Divide by 7, and you should get y equals 6. So that side is 6 feet. And now we filled in all the missing sides on both triangles. All right. Hopefully you're starting to get the idea. I think color coding really helps so you can see each side clearly. And let's look at example 3. Again, the triangles are kind of flipped around, and so it helps to use the way they've labeled the triangles in the problem. It says that triangle ABC is similar to triangle PQR. So that means that side AB here, lines up, corresponds with side, let's see, PQ, right there. Those are the hypotenuses of a right triangle. And then, I have to be careful, side BC, the second two letters line up with QR. So BC lines up with QR, corresponds with QR. And that third pair is always that last side, PR, corresponds with AC. All right. Then we just find our proportion. Let's see. We have the two blue sides. We have the two hypotenuses. And I'm going to go left to right. So I'm going to say 30 is to 10 as, and I can choose to solve for x first or y first. It doesn't matter. I'll go ahead and solve for x first alphabetically. 18 is to x. And again, left to right or big to small, however you want to look at that. So I have 30 times x equals 10 times 18. That's 180 equals 30x. Divide by 30. Divide by 30. Let's see, that should be 6 for the small side here. Do that whole process again for the other missing side. Using the same proportion, the same ratio here, 30 is to 10, as this time I'm missing the big side, so it's going to be y is to the small side, which is 8. So 30 over 10 equals y over 8. Cross multiply, that's 240 equals, cross multiply here, 10y, divide by 10, that should be 24. So this longer side here is 24. We're measuring in meters. Okay, so far so good. Just set up those proportions correctly and it's easy from there. Finally, example 4. A flagpole casts a shadow 99 meters long. At the same time that a different pole, 10 meters tall, casts a shadow 18 meters long. They drew a picture to help us understand. This time all we care about is this one missing side. They want the height of the flagpole. They gave us the lengths of the two shadows. Those are going to be proportional. These are right triangles. And shadows at the same time are always proportional. So we can go small to big here. The shadow on the small one is 18. The shadow on the tall one is 99. And that equals the height of the short one, 10, over the height of the flagpole, which they're calling h. So I'm going to use h as well. And once you have it set up, it's the same deal. Cross multiply. 18h equals 99 times 10, which is 990. Divide by 18. Divide by 18. Run that calculation. I got 55. 990 divided by 18. And so what that means is that the height of the flagpole is 55 meters. And they do this a lot to get the heights of buildings if they don't have the equipment to measure. But it's the same idea as a similar triangle.